All right, hello everyone. We're gonna really quick make a bolt today. I apologize for any noise. It could be a 3D printer, it could be buses or lawnmowers or whatever. We went over in class today about the different bolts, different types of heads, that sort of thing. This is all in the reference document shared with you. Along with that are two reference charts here, which we're going to take a look at today. So we're actually going to create a 1/4 inch bolt. Um, or rather the actual shaft of it is going to be 1/4 inch. So some of these measurements here, right, are typically made standard, which helps us out. So I'm going to give you some of those measurements today, and we're actually going to reference the one for the lock nut here, or not the lock nut, just the regular nut here, to create a complete fixture. So let's see if we can't set a time of about a half hour. We're going to try and blow through this. So real quick, we're going to go into Fusion 360, and you're going to create a sketch. The sketch that we're going to create is going to be along this vertical here. So we can go ahead and create a sketch by using our tools up here. So by grabbing the line tool, we're going to make a line upwards that is going to be 1.25 inches tall. Again, before we get started on this, you want to make sure that your units are set. We always change our units by going up here in the top right and going to preferences. Underneath there, we can go ahead and make sure that we're in the proper units for inches. You will have to relaunch the software, or rather create a new design in order for it to take effect. It won't work in this document, so you would just change that under there, drop down to inches. That's right there. Yours might look a little bit differently. I know I'm working on a slightly older version. It's the same stuff, just might look a little different. All right, so we created our line up this 1.25 or 1.25 inch. We're going to come on over from the left here. I did include this handy little reference image inside of my document here, which gives you all those measurements. So we're going to come over 0.125, 0.188 is going to be the head. So I'm actually going to draw this one first. I'll make my bolt upside down. Why not? And we'll take it from there. So jumping back into Fusion, I'm going to come on over. It's going to be 0.188. It's going to be the head of my bolt. We're going to come on up about a 1/4 inch. I'll type 0.25. You can also type 1/4. I like to move these little dimension lines out of the way just so I can see. So I drew this line, and then this line. The one up here is a little bit different. So this is the width of my bolt. The width of my bolt is going to be a 1/4 inch. But because we're going to revolve this, we need half of that measurement. So half of that measurement happens to be us coming over here. Half of 0.25 is 0.125. Wow, look at that. That's some math. All right, great. So we can bring this all the way down till we get close to hitting that. You can go a little bit further since we're just going to use the trim tool. I'll bring my line tool in and draw over. And just like we would in AutoCAD, we grab our trim tool and we delete this line. Very good. So now we have a shape here. So we can go ahead and click Finish, and we can select our bolt. We're going to go ahead and perform a revolve tool. So we're going to select, see it auto-selected my axes. So over here, we can just click off of those. From default base view, our profile is our shape, and our axis is the center there. So we can press OK, and we're good to roll. So now with our bolt set, we do have to create a hexagon head. So we're going to rotate to the bottom, select the top, and this is where we're creating our sketch. So if we hit create sketch, it's going to ask me where. I select the top of this, and now we're drawing on it. We're going to create our hexagon head. So underneath create, you can go to polygon and select circumscribe polygon. I know I'm going really fast today. A lot of this stuff is pretty basic. You can stop, rewind, whatever. You can put me in slow-mo if you want, or feel free to ask in class for some help, but they should hopefully provide guidance. So again, I went to create, and I selected polygon, circumscribe polygon. Make it whatever size. Doesn't matter, all right, because we're going to change it. So once you draw that polygon, make sure you don't type in measurements, because if, for example, I were to make that polygon and I type in, 0.4, I can't change this now without changing my center number, and we don't want to do that. We want to scale it afterwards. So we can select our dimension line. We're going to select one end of this and one of it down here. Drag this out, and we type in our measurement. Okay. So I believe on this measurement, I said that it was going to be 3/16 for the hex. Okay, 3. So it's going to be 3 divided by 16, which gives you 0.188. Fantastic. So that's my head right there. So we can click Finish Sketch. We're going to go ahead and grab this screw head, and we're going to extrude it downwards. We're going to extrude it down a distance of -0.15, and you're going to press OK. After you do that, you're going to hold the shift key, select the lines all along the top, and we're going to go to modify, and we're going to select the chamfer tool. The chamfer, we're going to do 1/64th. We're going to press enter. Look at that. Delightful. Now we're going to bevel out the top here to make it look a little bit neater. So we'll do a fillet this time. And we're going to do 1/64th yet again. We'll do the same on the bottom. So fillet, you could select them both at the same time if you want, but we're doing 1/64th for both of them. Great. That looks awesome. All right. So now it's time for us to go ahead and add our thread here. So we can select the main part here, go to create, and we're going to select where it says thread. This thread is going to auto-generate because we made our bolt a 1/4 inch. You'll see that as ANSI. So this is the standard units that or the standard, I guess, protocol we'll only use, or standard for our threading. 3A is what we want. 3A is just typical accommodation. 3B will be what we have on the inside of a hole for the accommodating nut, which I'll show you in just a little bit. And the direction here is which hand it takes to rotate. You can see if I change that, it shifts the rotation that you'll need to insert it or remove it from something. Typically, things are right-handed unless you're dealing with something like a propane tank, in which it would be reverse threaded or it would be left hand. But for today, we're going to leave it as right hand. So that looks perfect. Full length is neat. So if we were doing, like, let's say a carriage bolt, you may want maybe the top end of your bolt here to be smooth and this to run all the way to the bottom. But for today, we're just going to go the full length since we're not doing anything that requires, maybe a tire or something to that effect. So again, we selected it. We want to create and select the thread. And the settings should be basic for you. If yours doesn't look like mine, over here under document settings, you can go to where it says threads modeled, and you can click the little pencil icon and change this from cosmetic to modeled, and you should set that as the default. You just press OK. Great. All right. So we've got this set, but we still have to make our nut to accommodate this. So what we're going to do is if we look at our reference image over here, right, we scroll up, we're making something that's going to fit our 1/2 inch. I think I said 1/4 earlier. I misspoke. We're looking for, no, I was correct. I'm sorry. It was a 1/4 inch screw. So we're going to look at the 1/4 inch here, and it's going to give you some measurements. So we have S, which is the width, which says that it should be, a maximum of 0.5, which we'll do now. And our K value, or width, happens to be 0.25. And then we'll deal with the center in just a minute, because the center we know is going to be a 1/4 inch. So unlike most things when we do tolerance, we're going to make this exactly perfect 1/4 inch because our threads will accommodate and cut into our device to allow it to actually mesh. So let's try it now. So in Fusion, we're going to go ahead and create another sketch. I think it's good practice to make sure that you're naming as we go, actually. So before we do that, we'll go in here into bodies, and we're going to rename this. You can either double click it, or you can, I believe, right click it, and it should have an option here. You can go into properties, but you can just click it, double click it. And we're going to call this our hex bolt. Great. And under sketches, we have a sketch here, which is our bolt profile. So we can call that bolt profile. Great spell. And this thing here is going to be our hex profile. Very good. So what we're going to do is we're going to create a new sketch. Like I said, we're just going to do it on the horizontal here, or on the ground here. And we're going to create off to the right a polygon. Circumscribed again. And again, any size you want, because we're going to change it right now. So with that created, we bring in our dimensions again. Again, I always measure side to side, never ever on the point to point. And we can go ahead and actually, I don't really like the way that looks. This is the same thing. All right, and we're going to make this 0.5, just like our reference chart says, so 1/2 inch. So if we'd like to, we can create the hole now, or we can use the hole tool in just a little bit. I guess it's fine for us to use the hole tool. Why don't we try something new today? So we're going to hit finish sketch, and we're going to extrude this downwards a 1/4 of an inch, just like our diagram said, 0.25, press OK. Great, now we have our locking nut, or rather I should just say nut rather. We're going to cut into it, so we can go ahead and go to create and hole. If you don't see the option, you go to the drop down on our ribbon bar. So we'll select create hole, and the hole type is going to be standard, I guess. So we'll select this face here, and we'll set it to the center there. So we know that our hole is going to be a 1/4 inch. So the depth of it, really, it just has to go through. So anything bigger than a 1/4 inch is totally fine. And our width here is going to be 1/4 inch. So this will be 0.25 to match your bolt. Taper angle, we're not concerned with. There shouldn't really be a taper, and we're okay there. So we can press OK, and it should cut through my nut there. Awesome. Now we just have to add the thread. So just like we did before, we select the inside, and we go to create and thread. This time you'll notice it says B. The size should still be a 1/4 inch, and it should still be an ANSI. It's also right-handed, so we're good to go. We'll just press OK. So now we have a thread on the inside of our nut that'll accommodate our bolt, and that looks pretty good. To make it match up with what we did over here, it might be a good idea for you to select all of these lines here, and we're going to do a quick chamfer. So a 1/64 chamfer around these. So we'll go to modify and select our chamfer, and we'll do 1/64, press enter, and we can do the same thing on the bottom. This is usually how you'll get them machined. They're not typically flat, so for best practices and to really get the full effect of this, we're going to make sure that they match. Be careful not to select the wrong faces. If you do, you can, while holding shift, click it again and it'll deselect it. I held shift to select all of these. So we're going to modify and go to chamfer, and again, it's 1/64. You'll hit enter, and bam. Awesome. So just to keep myself, accurate over here on the left, I'm going to make sure that I'm renaming things as I go. So this is going to be our nut profile. Fantastic. And we're also going to change this body here to a hex nut. Perfect. All right, so everything's nice and labeled and neat for us. However, we're not done, right? If I wanted to 3D print this, I would have to make sure that both of these are on the same plane. But for today, we're not going to print them. We're actually going to simulate motion with them. So to do that, we're going to create something new, and that's called a component. So components, right, are portions of a larger thing called an assembly. So just like a machine is made of several parts, we're going to create a assembly out of several components. So each of these individual parts here will be its own component, which when together will be a threading, assembly. So we're going to go to create, and we're going to select new component. We're going to go ahead and select our object here, and it's giving me an issue. So we're going to make sure standard, internal, external, from bodies. That's it. Okay. So over here on the right side, you want to make sure that you have it checked so it says from bodies, because otherwise it's going to try and group everything. So we're going to do one at a time. We'll do our hex bolt first. We'll press OK. And now there is a new component. Wow. Okay, so it says hex bolt to 1, which is great. And now we're going to select the hex nut and go to create, and we're going to select component and make sure it says from bodies. Otherwise, you're going to get some issues. And we're going to create it from our hex nut. So now we have our bodies tab disappeared because now our bodies are being recognized as components, which means we can assemble them. So it's pretty straightforward. So now we're going to actually put them together. So under the assemble tool here, we're going to select joint. We can press the letter J. And we're going to snap these together. Now the first one that you pick will be your moving body. In this case, we want the hex nut here to move about the bolt. So we're going to go ahead and select our snap. And you'll see if I mouse over this, a bunch of icons show up, or a bunch of dots. So when we zoom in, I want that center dot right in the middle of my hex nut. So when I mouse over it, I'm going to hold control, and go to the center dot. If I don't hold control, it'll disappear as soon as I mouse to the center. Check this out. All right. So if I go ahead and I try and create a joint, symbol joint, and I don't, it just disappears. It makes it really hard to select. So with it moused over here, hold control, select that center dot. Goes in Viz, which means we selected it. Very good. Now it's asking me for component 2 over here. Component 2 is my hex bolt. So we're going to rotate to the one side of it. We're going to mouse down here. I'm going to hold control and select the center. As soon as I do that, it should snap to it, move to its position, which means that, hey, we're in the right spot. Now it's starting to move. It's starting to do some actions here, but we're not sure how it looks yet. So we can check that under the motion tab here, and we can change this to a cylindrical rotation. If we press play, it'll kind of preview what it is that we're going through or for. If you aren't happy with the placement of this, this is one option you could change, was the flip over the origin. So if something seems off, you can flip that. I like having it start on there so it looks a little bit better. Some people may prefer for the simulation to have it off. It's really a personal preference, or based on the part it is you're engineering. This could be, very different if we were trying to simulate a slot on a conveyor belt or something. So we're going to save this and just press OK. So we have the start of this, but right now it's not perfect. Right now it doesn't rotate. It doesn't really do what I want to do. That's me grabbing the flag there. So we're going to press escape. We don't want to do that just yet. So we're going to go underneath our assemble, right? And we want to go to, actually, I'm kidding. Under joints here on the left, we're going to go to our cell. You're going to right click and you're going to go to edit joint limits, edit the limits. You're going to set a minimum and a maximum, and we're going to change it from rotate to slide. And so you're going to see that we want our minimum and our maximum to be set such that the minimum, right, should be down here, and the max is when we see this thing travel all the way up here. You can see it by pulling it that way where you want it to end. So based on my bolt, I think -1 should be my minimum. My maximum should be 0. All right. Now, if I wanted to animate this, you can see it rotate back and forth. Now we see it go over just a hair, and that's because this is 1.10. So we'll change that to 1.0. And now you'll see it works right, but it's not quite rotating as it should. Right now it's just sliding. So let's fix that. We press OK, and we're going to add what's called a motion link. So we can right click onto the joint and go to, this is the one that we have to go under assemble. So when you go under assemble, you select motion link, and our motion link is going to be, yes, that joint should auto select it for you. It's the only one that we have. We're going to hit link with same joint, and you see it's going to allow me to rotate on the Z, which is pretty good. Now it's interesting because if you adjust this, like let's say we put 720 in, it just rotates a lot quicker. Okay, but for our purposes, we're going to leave it as 360 and press OK. And now that we have it working, we should be able to grab our motion link now and pull it and see it actually rotate up and down. If I wanted to play it, I could just go into motion link and go in and edit it and see it work just as it should. Okay, fantastic. And so that's my completed bolt here. What I would like you to do in class is to attempt to do the same thing, but we're going to scale it up just a little bit, right? So we're going to try a slightly different bolt, which I'll give you in class as a challenge. You want to make sure that you're looking at your bolt reference chart here. So if, for example, I have a strong feeling we'll be doing a 1/2 inch one, we'll look here and look at the max for S, which is our width, which for a 1/2 inch is 0.875. Our K value, which is the thickness, and so for a 1/2 inch is 0.504 is our max. Again, this is a tolerance range for like when they're manufactured. We're just going to rock the max to keep it simple. And our D, which is probably the most important, right, is always going to be 1/2 inch. There you go. All right, if you have questions about this, please feel free to reach out to me via email. Thanks very much, and talk to you soon.